The observable universe contains billions of galaxies, vast islands of stars, gas, and darkness. Yet we are confined to a single spiral arm of the Milky Way. What if our very survival depended on leaving this arm behind? Imagine a future where humanity must choose a new galactic home. A spiral, an elliptical, or an irregular. Which destiny will we forge, and which will erase us? We are still a subgalactic civilization, barely mastering our own solar system. In the next 9 minutes, we will accelerate humanity's interstellar odyssey, examine the physical, biological, and societal challenges of each galactic class, and confront the great galactic filter that may decide whether we become a universal species or a fleeting whisper. Let us first lay the theoretical groundwork that will illuminate our path. A galaxy is a gravitationally bound collection of billions of stars, dust, and dark matter. The Hubble classification arranges them into 3 principal families. Spirals are rotating disks with elegant arms rich in molecular clouds and newborn stars. Ellipticals are spheroidal, dominated by ancient low-mass stars, almost devoid of gas or dust. Irregulars are chaotic, often the remnants of violent collisions, with frenzied star birth rates and turbulent gas flows. Why does shape matter for life? Gas and dust provide the raw material for planets and the chemistry of life. Radiation environments set the limits of habitability. Gravitational dynamics determine the stability of long-term settlements. In a spiral, the dense arms offer abundant energy, but also relentless supernovae and cosmic radiation. An elliptical offers quiet longevity but scarce fresh material. An irregular presents raw power and constant upheaval, demanding adaptability beyond anything we have yet imagined. Our starting point is a fragile foothold in a single spiral arm. Before we can leap between galaxies, we must first secure the Milky Way itself and survive the inevitable collision with Andromeda that will reshape our cosmic neighborhood in several billion years. This is the crucible in which any intergalactic ambition must be forged. Consider the first scenario, expanding within a spiral galaxy, the environment most familiar to us. The dense arms are laced with molecular clouds, fertile nurseries for stars and planets. Humanity would likely deploy self-replicating probes, machines that harvest local resources to build copies of themselves, spreading like a digital fungus from star to star. Around each sun, colossal Dyson Swarms could capture the full output of stellar energy, feeding a network of habitats and computational cores. These habitats would be linked by laser-based communication grids, forming an interstellar internet that spans the arm. The advantages are striking. Continuous access to fresh material fuels perpetual growth. A lattice of energy-rich habitats could support a civilization of unprecedented scale, with minds linked across light years, sharing knowledge in near real time. Yet the very beauty of a spiral hides a lethal hazard. The spiral arms are also regions of high stellar density, where supernovae explode with terrifying regularity, bathing nearby systems in lethal radiation bursts. To survive, humanity would need to master the control of space weather on a galactic scale, perhaps by deploying massive magnetic shields or by engineering the timing of star formation itself. This leads us to the great galactic filter. If spirals are perfect cradles for life and expansion, why do our telescopes not reveal megastructures in neighboring galaxies? The answer may lie not in technology alone, but in the immutable speed of light and the vast emptiness between galaxies. Crossing intergalactic voids demands journeys that span millions of years, far beyond the lifespan of any biological organism. To bridge that chasm, humanity would have to shed its fragile flesh, becoming a digital consciousness housed within colossal Matrioshka brains, nested computational shells that turn entire stars into processing units. Only then could we transmit our essence across the darkness, sidestepping the tyranny of mortality. Now picture the second scenario, venturing into an elliptical galaxy, a giant amber sphere of ancient stars. Here the night sky would be a dim, uniform glow, the cosmos quietly aging, with almost no gas left to birth new stars. The environment offers a scarcity of fresh resources, yet the deep gravitational well of the central supermassive black hole holds untapped energy. A civilization that has already mastered stellar engineering might begin moving entire stars, redirecting them toward the black hole's accretion disk to harvest its radiant power. Life would no longer depend on planetary surfaces, but on the slow, steady output of low-mass red dwarfs that shine for trillions of years. The existence would be one of low consumption, eternal endurance, and a profound detachment from the vibrant cycles that once defined our world. The third and final scenario takes us into the realm of irregular galaxies, chaotic clouds torn by gravitational collisions. Here star formation erupts at a furious pace. Massive stars live brief, explosive lives, and supernovae pepper the void with shockwaves. To survive, humanity, now a hybrid of artificial intelligence and quantum consciousness, would have to become true architects of the cosmos. Massive planetary-scale lasers could be used to shepherd comets rich in resources, stabilizing orbits amid the turbulence. Civilizations would be nomadic, hopping from one nascent system to the next before each host star detonates in a hypernova. This existence demands perpetual adaptation, a constant redefinition of home, and a willingness to embrace chaos as a source of creative energy. All three pathways reshape humanity beyond any current imagination. We would move from inhabitants of a single rocky world to a consciousness that orders the very fabric of the universe. The galaxy we choose will dictate whether we shine brightly in the chaos of an irregular, linger in the quiet immortality of an elliptical, or expand methodically within the familiar arms of a spiral. But before we can answer that, we must first learn to tend the only vessel we possess today, Earth. What do you think would be the greatest challenge for humanity in any of these galactic destinies? Share your thoughts in the comments, and if this journey is opening new horizons for you, consider subscribing so we can keep exploring together. Imagine for a moment that the very act of looking up at the night sky becomes a rehearsal for an exodus that transcends the limits of a single galaxy. In that rehearsal, every choice we make today, how we treat our oceans, how we manage our climate, how we negotiate the borders of nations, writes a line in the script of a future where humanity may have to navigate the vast, indifferent corridors of intergalactic space. The stakes are no longer confined to the preservation of a single biosphere. They become the preservation of consciousness itself, a spark that could illuminate the darkness of a spiral arm, linger in the dim glow of an elliptical heart, or dance amidst the tumult of an irregular storm. Yet the path to any of those destinies is paved with challenges that dwarf our current ambitions. First, there is the fundamental barrier of physics. The speed of light remains the ultimate speed limit, and even with breakthroughs in propulsion, a journey across 1,000,000 light-years would span epochs far beyond a single human lifespan. Overcoming this would demand a radical rethinking of identity, perhaps the relinquishment of flesh in favor of pure information, stored in colossal, self-sustaining matrices that can survive the cold void. Such a transformation raises profound ethical dilemmas. Would a disembodied intellect still be human, or would it become something altogether new, a post-biological entity bound only by the laws of computation? Second, the environments themselves pose existential threats. In the densely packed arms of a spiral, the relentless barrage of cosmic rays and frequent supernovae could strip away delicate habitats in an instant. Mastery of stellar engineering would be required not only to harvest energy, but also to shield colonies, perhaps by constructing immense magnetic domes, or by positioning artificial moons that deflect high-energy particles. In an elliptical galaxy, the scarcity of fresh gas means that new worlds will not be forged. Civilization would have to rely on the slow, steady output of ancient, low-mass stars, demanding an economy of extreme efficiency and patience. The irregulars, with their chaotic bursts of star birth and death, would force humanity to become perpetual nomads, constantly relocating before a neighboring supernova renders a system uninhabitable. Each scenario tests the adaptability of culture, governance, and the very psychology of a species accustomed to stability. Third, there is the social dimension. A civilization that spreads across light years will inevitably fragment. Communication delays of years, decades, or even centuries could give rise to divergent cultures, each interpreting the original mission in its own way. Would these branches remain united under a common purpose, or would they splinter into isolated enclaves, each pursuing its own survival strategy? The answer may hinge on the development of a shared, perhaps even transcendent value system, one that places the continuity of consciousness above planetary allegiances. All these considerations converge on a single, immutable truth: the future of humanity. Whether it unfolds among the graceful spirals, the solemn ellipses, or the wild irregulars, will be shaped by the choices we make today. The technology to launch interstellar probes, the political will to fund long-term research, the moral courage to contemplate leaving our home world. All of these are seeds we plant now. If we nurture them wisely, the seeds may one day blossom into a network of luminous beacons, each a testament to a species that refused to be extinguished by the cold march of time. So as we stand on the brink of this speculative odyssey, reflect on the paradox at its heart. The more we look outward, the more we must turn inward, confronting the limits of our imagination, our ethics, and our unity. Which galaxy would you choose to call home? And what sacrifices would you be willing to make to ensure that humanity's story continues among the stars? Let those thoughts linger as you go about your day, and when you feel ready, share your perspective in the comments. If this exploration has sparked a curiosity that reaches beyond our planet, let a like be the signal that this journey resonates with you, and consider joining the community that seeks to unravel the mysteries of our cosmic destiny. Together, we can keep the dialogue alive, charting a path from the fragile cradle of Earth to the boundless horizons that await.